Okay, today we are going to start to ramp things up with friction. So what's going to be different? Let's find out. Here's what we have. We have a box on an angle, right? Let's say that there's some kind of friction on here. It's who cares what. So let's say it's got a mass of M. So we're going to have a force here, which is mg. So far so good, I hope you know. And then we are also going to split it apart into our down the angle stuff here. So this is going to be our theta, this is going to be mg cosine theta, and this is going to be mg sine theta. Right? So you have to split that apart because here's your normal force, right? Your normal force is changed, mg cosine theta. But here's the problem. Your frictional force is going to also be affected because your force of friction is going to equal mu times your force normal. Okay? Now, since this is your force normal, that's what you're going to have to use for this here formula right there. So your force of friction is going to equal mu times mg cosine theta. Now, you don't have to memorize this stuff, but you need to be aware of how it's calculated, and that's what really matters. So, if it's sliding down there, you'll have this force that's pushing it down and this force that's pulling it up. Now, it depends on the angle if it will slide or not. There's that. Hold on till the end of the video and we'll do a fun problem like that. But let's do an easy one to start with. So how much force to pull a 15 kilogram box up a 30-degree angle with a mu of 0.5? Alright, we've got a suspiciously familiar picture here. So this is a 15 kilogram box, which means it has a force of gravity equal to 147 newtons. Now this box can be broken apart into component form. This is a 30 degrees. So this is a 30 degrees. That's a right angle. It just doesn't look like it. So we are going to have 147 times the sine. Oh, let's do sine first. What the heck? Of 30, and we get 173.5 newtons. And then when we do its brother, we're going to get a 127.3. Okay, so far so good. Let's put all the other forces up here. We're going to have a normal force. We know what the normal force is. It's going to opposite this one here, 127.3, because that's where it's at. So we're pulling the block up this way. So friction force is going to be pulling it down. So friction force, remember, is going to equal mu times your force normal. So mu was 0.5 times your force normal, which is 127.3. Alright, so let's figure out what that is. So that's going to be 63.7 newtons. Ta-da! Okay, so now that we have that, so now we got to figure out what this F needs to be to pull it upwards, right? Well, it's got to be bigger than the forces going down. So let's set them equal to each other. What's going down? You have your force of friction, and you also have your force of gravity. That's parallel. You have this guy going down too. These two forces are both pointing down the hill. So your pull has to counteract both of them. So your friction is 63.7, and we have to add in a 73.5. So that together is, so 63.7 plus 73.5, and we get a 137.2 newtons. So that's how much force it takes to pull up the box, right? Ta-da. So let's do one more. Two more, I think, whatever. What's the acceleration of a 20 kilogram box on a 40-degree slope when it's pushed up with an angle of 150 and mu equals 0.3? Alright, let's draw a beautiful picture. Now yours might not look as great as mine, but, well, you can always look at mine and weep. Anyhow, so pause the video, see if you can figure it out. I'm going to keep going because once you pop, you just can't stop. Product placement. Okay, so 20 times 9.8 is 196 newtons. We're going to split it up. This is a 40, right? Yeah. So we're going to have 196 sine 40 equals 126, basically. And then the brother is 150.1. 0.1 newtons. Ta-da! So we know that the normal force is 150.1 newtons. So it's pushed up with a force of 150. Now the frictional force is going to be FF is going to equal what's that? Alright, let's get this taken care of. So 1 times 0.3, so 45. Mu times force normal. Mu is 0.3 times 150.1, and we get 45. Alright, now which way is it going? That's what you're wondering, right? Well, let's think about it here. It's being pushed down with 126, up with 150. Right? So far, so good. But Mr. Keeney, the friction's going to be less, or the friction's going to make this one more, because 126 plus 45 is going to be more than 150. Yes. But here's the deal. Without the friction, if it were starting to move this way, then the friction would go to the other side, and it would stop moving again. So here's the deal. What's going to happen is, it's not going to be moving. The friction is going to be holding it in place because you are counteracting the weight, almost, basically, or you're really close to that, and the friction is making up the difference. Now, some important thing to keep in mind is that when we calculate friction to be 45, it's not always 45, it's up to 45. Alright? Give you an example here. Here's a box that weighs 100 kilograms, which means it weighs 9,800 newtons, which means the normal force is 8,800 newtons. Now if I push it this way with a force of 1 newton, the frictional force, if the mu, let's say mu is equal to 0.1 to make it easy for ourselves, so that means the force of friction is going to equal 980. It's not going to shoot to one side. The frictional force is just going to match the 1 newton that I put in. Alright? Now, I'd have to push it 981 newtons to get it to move to overcome that. But the friction force isn't going to go max out against nothing. Alright, I think we got one more. Yeah, the fun one. The foreshadowed one. If your shoes have a mu of 0.6, what is the steepest angle you can be on? Well, let's think about it here. You're standing on a slope. Beautiful. It's at some angle here. Here's your new shoes. You look awesome in those shoes. Now, gravity's pulling you down. Friction is holding you up. If friction's strong enough, it can hold you up for a steeper angle. What's your angle? Well, let's figure it out. But I don't know how heavy I am. Doesn't matter. So we're going to have mg This one is going to be mg cosine theta. This one is going to be mg sine theta. Your normal force is going to be mg cosine theta. Gravity or friction's going up, so friction is going to be mu mg cosine theta, right? Multiply the normal force. Now, you've got two forces that need to cancel out. This force and this force, right? The up and down forces are already guaranteed to be equal, so those don't matter here. So what we know is that mu is mu mg cosine theta, that's your friction force, has to equal the downwards force of mg sine theta. Now, hopefully you can tell these things go away because they cancel out both sides. So now we have mu is equal to mu cosine theta equals sine theta. Well, let's divide by cosine theta. So we have sine theta over cosine theta. How do we simplify that? Well, this was an easy trig identity. Hopefully you remember this one. This is tan theta, right? Sine over cosine equals tangent. So what are we going to do? We're going to do the arctangent. Tan minus 1 of 0.6 is equal to theta. Alright, tan minus 1.6. This is equal to basically 31 degrees. So that's the maximum angle your shoes can handle. Now your muscles, this doesn't take into account. That's up to you. Do ya even lift, bruh? Anyways, hey, that's it for physics for the short week here. Hopefully it didn't drag on through the friction, right?